This video I'm going to talk about process of debugging assembly code lah. So here on your screen there's a given an assembly program is provided lah where we assign numbers to variables and we perform arithmetic operations to, to them with them. We store the result in a variable called final value. Right, so now I'm going to explain about the process of debugging lah. Since you since you already know from the comments here that you know what the program does lah. So when you actually hover over this this bar on the left side, you can see circles appearing like white circles, right? So these are called, you can enable or disable breakpoints by left by left clicking lah on here on any point lah. If you want your program to stop at this point when you start debugging, then you press here, or you can press here as well. Press anywhere lah. Alright, so let's start debugging now, since this is the beginning of the execute executing the part to be executed lah. So the code part basically. So we just press here local Windows debugger and we'll start debugging. And you see some windows appearing lah. Memory 1, registers, watch. These are the three important ones lah, that are used for debugging. And just in case this window not popping up, you just here go to debug, go to Windows, and then you just find memory. I choose memory 1 lah for this, and then registers, and also watch to just watch how the variable change each line by line. Right, so we add item, right? Name, we just add the variable name lah here, val1, right, 10,000, as you can tell from the value. Val2, 40,000. Val3, right, Val3, 20,000. Okay, so if we if you want to go to the memory of that variable, right, you just use ampersand and then you just type the name val1. Okay, and then some numbers will appear. This is little endian. So basically the the two of the leftmost bits are the least significant, and when you look at these two bits, right, the right one will be the least significant, followed, and the left one will be the next most significant lah of the two bits. It just basically this memory window, right, it separates the bits into 2 bit by 2 bit basically. So if we, for example, you see like val1, like the value is 10,000. Okay, so there's 4 zeros, right? So one, right? So these 4 zeros are in a wait, so sorry. Okay, and so there's 4 zeros, obviously. So here it will be all zeros. Okay. Then the one, right? The one, right? The one is the least. Just as I said, the one is the least significant of the 2 bits. So that's why the one appears on the right side instead of the left side. And then zero is here, right? So basically this and this are the same, right? So zero, so val two, val two like 40,000, and val three it's it's by 4 bits, right? Every variable is separated by 4 bytes because double word, right? Double word with 4 bytes. Yeah, 4 bytes. 4 bytes, 32 bits, right? So that's why they're separated by 4 bits. So, like 8. Okay. And the final value should be like 12, 406012, right? I suppose. Assume like 40. Oh, since this is in hexa, right? So you see. Okay. Alright, now let's go to the registers, which is more important now. Initially, the register has this value, and if the arrow indicates at which at which point of the program we are in. So if it's in first line, right, it means that the first line hasn't been executed yet. It's just frozen in at this point. And if we press F10, right, it will move the arrow will move to the next line. So that means that it will move to the second line, and then the first line will be executed, and the program will be frozen at the second line. And as you can tell, the EX now has 10,000 because the first line, like we tell the computer to assign 10,000 hex to the register EX. Alright. And then if we press F10 again, right, we should expect EX to have a value of 50,000 because we add value 2, which has a value of 40,000 hex to EX. So we should get 40,000, 50,000 in total, right? Yep, 50,000. And val 3, right? And after, if we press F10 again, right, we should expect get 30,000, I think, because we subtract the 20,000 from EX. Yep, 30,000. And then I haven't added final val here, right? Sorry, zero. Right? Okay, now final val. Since final val doesn't have a value, right? Right now, right? As of now, it has a default value of zero lah. I think that's what default value is if we do not initialize it. If we do not assign a value to it when declaring it. And if we press F10 again, right, we should expect final value to change its value to 30,000. Right, I think so. Right? Yep, 30,000. Yeah, as you can tell here, the value change. And then the call dump rec is for the command prompt. Right now it's blank screen. Right? If we press F10, wait, if we press F10, right, now the registers will all appear lah. Will display all the registers lah relevant to this program. And exit means exiting the program lah. If we press F10 and then we will exit from this program. Yep. And then yep, of course. So this is for the lab 1B. Alright, so now I'm going to go to lab 1C. Lab 1C, right? This is going to be a school. Easier. I think same process, right? Basically, it's just the same process, right? So yeah, should be same like just now as. And then the one important part, right? I haven't discussed is about the disassembler, right? Wait, this important. Wait, disassembler. Yep, yeah, yeah. Then we show the code bytes. Right, this one is the address where the instruction is stored, right? Instruction. Yep. And this one is the instruction code. Basically, the machine code, like it changes. Depends on the computer, lah. Because different computers have different instruction code, instruction encoding, right? Basically. So for my computer, the instruction code is as follows, lah. It's like this: 66A1, whatever this means. And then this one is for the add one, and this one is for the subtract one. Okay. And some codes are like 1, 2, 3. Some codes are shorter, some codes are longer, depending on what it does, lah. Okay. So I think that's it, lah, for this debugging. I think that's all for this video. I hope you enjoyed. I hope you learn, at least you learn something from it. So thank you.